Okay, so question 30 now. It looks as if it's time for a hot drink. So here's the question. First things first, what I'm going to do is to draw a little sketch of what's going on. So this is a fairly straightforward linear model. We can see from the equation that the gradient is minus 0.03, so it's a negative gradient. So the line, the green line which I've drawn there, has got a negative gradient. So we're only interested in positive values of time on the x-axis there. So the 65 here is where the line cuts the y-axis, and the gradient is minus 0.03. So that's what the values 65 and minus 0.03 mean. But the question asks us to give an explanation in the context of the question. So in the context of the question, when t equals 0, little t is 0, big T, the temperature, is 65. So 65 in context is the model's estimate of the initial temperature of the drink. And the gradient, the minus 0.03, indicates that the drink is cooling, according to the model, by 0.03 degrees centigrade every second. So what we've done now is to interpret the values 65 and minus 0.03 in context. What about the next part of the question then? So the observations which have taken place in order to create this model have all been between 30 and 600 seconds. So they might have been like this, for example. And over that period of time, from 30 to 600, this straight line is a good approximation. So if we want to use that model to make estimates anywhere between 30 and 600, estimates of the temperature of the drink, then that's fine. And that's called interpolation. But if we want to make estimates for times outside of that range, 30 to 600, then we're taking more of a risk, because in fact, it's unlikely that the temperature will continue in a straight line. If it does, then by the time we get down here, we've got a negative temperature. Also, it's likely that the initial temperature, initially the drink will cool down quicker than it does later on when it's getting closer to room temperature. So the problem when we go outside is that we're likely to, outside this range of 30 to 600, we're likely to get estimates which are less accurate. And so this is called extrapolation. And so that's why it wouldn't be sensible to use the regression model to predict the temperature after 15 minutes, because 15 minutes is out here somewhere, and therefore unlikely to be accurate. Hopefully you got the same answers I did. If you did, well done, and I hope I haven't made any mistakes.